peepcode. This screencast will show you how to use GNU Emacs, a powerful text editor. Actually, saying that Emacs is a text editor is somewhat misleading. It's also a Lisp interpreter, virtual machine, compiler, debugger, mail client newsreader, GUI, toolkit, documentation viewer, calendar window manager, terminal multiplexer, IRC client, file manager, XML parser, Tetris implementation, wiki, diff merge tool, typesetting system, VI emulator, spreadsheet conversation partner, version control interface, and socio-political statement. Not to mention with plugins, it can become all of these other things as well. But the important thing is that it's a Lisp interpreter. Lisp is a language from the 1960s that has pioneered nearly every feature we see in modern dynamic languages. Since all its functionality is implemented in Lisp, and Lisp is extremely dynamic, it's very easy to extend and modify functionality while it's running. This provides a degree of flexibility unmatched in virtually any other software. As a bonus, it also lets you edit text, which is where we'll start. Now, some say Emacs has a steep learning curve. When you start, you may not even know how to move around or open files, but stick with it and you'll soon become comfortable. The first 30 minutes of this screencast will get you to the place where you can probably do most of what you can do in your previous text editor: basic navigation, working with files, searching for help. Next, we'll talk about editing. Finally, we'll talk about modes which add powerful features to Emacs. If you're on a Linux-based system, you probably already have Emacs or use your package managers such as sudo apt-get install Emacs. If you're on Mac OS X, there are a couple different options, but in this screencast and in general, I'm going to recommend Apple's Carbon Emacs. Straight from Apple's site, you can download that. It's a fairly recent build and works quite well. It's also more consistent with cross-platform versions of Emacs, and then you can customize it as well if you need to add some Mac-specific key bindings. On Windows, download the precompiled binary from the main Emacs site at gnu.org. We'll be assuming usage of GNU Emacs 22 or later in this screencast. The release of Emacs 23 is just around the corner and should happen in early 2009. We'll cover a handful of features that are only available in version 23. Since Emacs is a Lisp environment, you write code to personalize it rather than clicking checkboxes or what else in the Preferences window. This has the significant advantage of allowing you to keep these changes in version control so you won't lose them and will be able to replicate them across every machine you use. See the Git peepcode screencast for info on the distributed Git source code control system. Your personalizations are kept in the .emacs.d directory in your home folder. There's also a file called init.el that gets loaded upon every invocation of Emacs. The default settings are not always very good for beginners, so we've included a copy of the Emacs Starter Kit, which is a set of Lisp files that provide useful customizations. Download or clone it from GitHub and copy that to your home directory. We'll show you how to link that up in a minute. Now, if you're using Aqua Emacs, this won't work. You'll need some extra customization. See the PDF that has accompanied this for details. Now, if you find yourself working on another machine that lacks your dot files, you'll be pretty disoriented as many functions and bindings you're used to will be missing. So be sure to make your dot files easy to install on all the machines you use. Your set of customizations is often referred to as your .emacs file, even though it's usually a whole directory. If you follow the conventions in the Emacs Starter Kit, you'll have a great start. One last thing is you'll need to link the Emacs Starter Kit to the .emacs.d directory or just rename it. Either way works. Brief tip: when you first start Emacs, you may notice a bunch of things compiling and you may see some warnings and other messages. These are completely normal and you'll only see that the first time you start with the Starter Kit. Now, the Starter Kit is organized to load your customizations from files with the name of your machine and or username. So if you want to create a custom file inside the Emacs Starter Kit, I've created one just called topfunky.el, and then whenever I'm logged in as the topfunky user, that will be loaded automatically. This also is a good way to keep your customizations separate from the other files in the starter kit so you can rebase easily without having conflicts. Another thing people like to do is have a vendor directory inside that has third-party plugins and libraries. But first, let's look at what you'll be looking at when you boot Emacs. Because it was originally written before modern graphical user interfaces, Emacs uses slightly different terminology than you might be used to. You may look at what we see on screen right now and call this a window. Well, Emacs calls that a frame. A frame comprises everything in what you would call a window, other elements, text, scroll bars, all of that. You can make multiple frames, and we'll look at that later on. Inside of a frame is a window. I have 3 windows open. Text editing happens in a window. Windows also show output from commands and can contain an Emacs shell or a terminal session. I have an implementation file, a test, and a shell here. Personally, I think this is one of the most initially interesting features of Emacs because you can organize your work environment and even set up some presets for different kinds of work and the different kinds of splits you want to see. At the bottom of each window is the mode line. This shows which window is active, the current line number, the current Git branch, and the major and minor mode, which we'll talk about later. At the far left, it shows an asterisk if there are unsaved changes. It even will tell you if you're on a file that hasn't been pushed out to your remote repository yet. At the very bottom of the frame is the mini buffer. As you issue commands, they'll be shown here. Brief tips, file navigation choices, and other content is shown in the mini buffer. You'll spend a lot of time looking at the mini buffer. Next, the keyboard. As mentioned, Emacs predates virtually all other extant graphical interfaces, so its terminology and key bindings have evolved along a different path from what you're probably used to. You'll see that Emacs commands are often bound to meta key combinations. On most PCs, meta means the Alt key. On the Mac, it's either the Command key or the Opt key. If you downloaded Carbon Emacs, it's the Command key with the flower on it. The Control key is also used extensively. Sometimes when you're working over SSH, your terminal program will not be capable of transmitting all the different meta key combinations. In that case, press and release Escape before the key instead of the Alt or Command key. When you see bindings written out, the prefixes C- and M- are used to mean control or meta combinations. Now, you wouldn't want to get Emacs pinky or green warty hands, so I like to remap the caps lock key to also function as control. You can go into the System Preferences in the keyboard panel to remap your modifier keys. Emacs commands come in several combinations. One is just a modifier key and a letter. For example, Control-N will take you to the next line. That's the easiest one. More common are multi-key combinations with modifiers. For example, Control-X, Control-F will open a file. Hold down Control, type X. While keeping your finger on Control, move your other finger over and hit F. Control-X, Control-F opens a file. Third, combinations with and without modifiers. Later we'll see CXB visit buffer. Hold Control, hit X, pull both hands off the keyboard, then hit the solitary letter B. Later on we'll see that on screen. Finally, every command is also able to be invoked by pressing meta X followed by the full name of the command followed by return. If it has a binding, you'll get a message reminding you of the binding so you can use it as a shortcut next time. Briefly, here's what these look like on screen. CX, CF, Control X, Control F, find file. That opens up the find file dialog. You could hit enter to select an item or start typing to narrow down the list. For example, even though I'm looking at it, I could start typing .emacs and that would narrow this down to all the directories that have those names in it. Hit enter to select one of those, which will then put me down into that directory. I could start typing, for example, the readme, hit enter again, and I have opened the readme file. A quicker way to do that, if you've already visited that file in the past, is just CX and then the solitary letter F, which will show you a list of recent files that you've opened. Here's an example of calling a function explicitly, meta X, and then start typing next dash line. This actually just takes the cursor to the next line, and it tells me in the mini buffer that I could have done that with Control N. We'll see that in the next section on movement. Finally, quit Emacs with Control X, Control C. It will prompt you if you have made any changes that you need to save. Next, I'll show you how to move efficiently within a file. One of the things I love about Emacs is how easy it is to get where you want to go, whether it's separate files or within a file. So next, let's talk about movement. While you can use the arrow keys to move around in buffers, it's discouraged. If you use the arrow keys, you have to take your fingers off the home row to perform simple navigation. While this doesn't seem like a big deal, it interrupts the flow of typing. The fact is that your fingers should never leave the home row during regular usage. This is part of the maniacal focus on efficiency that Emacs is known for. Even if it seems awkward at first, learning these key bindings will pay off. So here are 4 words to remember: front, back, next, previous. To move forward, Control F. Forward, 1 letter at a time, Control F. To step that up, and this will be a pattern, Meta F will send you forward 1 word at a time, Meta F. Or to go to the very end of the line, Control E. So again, Control F to go forward 1 character, Meta F, forward a word, Control E to go to the end of the line. Now, as I said, this pattern will repeat itself. So going backwards, we'll have Control B to go back 1 character, Meta B to go back 1 word, and then a unique Control A to go to the beginning of the line. Control B, character, Meta B, word, Control A, beginning of the line. Moving to the previous and next line also follows a pattern, though slightly different. Control P, previous line, Control N, next line. To jump a page up or a page down, it's Control V to jump down, Meta V to jump up. To get to the very beginning of a document, Meta left bracket. You may have to hit Shift to hit that key on your keyboard. To get to the bottom of the document, Meta right bracket. Here's one more that's useful just for realigning the screen so that you have the cursor in the middle of the screen, and that is Control L. Let's go to a point, hit Control L, and the screen will reorient itself so that cursor is in the middle of the screen. I went through those quickly, but look at the compass rose at the beginning of this section for reference. The other important movement trick to remember is iSearch. Pressing Control S will open a forward incremental search, or search as you type. While this is meant as a search tool, it also works great for navigation. If you're at the top of the screen and you want to jump to a specific point at the bottom, you could press Control V or a bunch of Control N's, but it's much more precise to just hit Control S and start typing a few letters from the target to jump instantly there. Control S again will jump to the next occurrence. Control R will perform the same for searches in the reverse direction. Use Return to get out of the search prompt and stop at the place where the cursor is, or Control G to cancel the search altogether and dump you back where you started. If you ever need a quick refresher on the basics of movement, just bring up the tutorial via Control H T. Here's one for TextMate fans. When you're in a code buffer, you can invoke IDO iMenu with Control X, Control I. This will prompt you with a list of all the functions defined in the current buffer and will let you jump to definitions quickly. Just start typing a substring of the function definition you're looking for. Control S will cycle forward through the options, and Control R in reverse, hit Enter to choose one. Instead of using visual tabs for keeping multiple documents open at a time, Emacs uses buffers. This has many advantages over tabs, not the least of which is that it scales to a very large number of open buffers instead of being limited by the width of your screen. Press Control X B to invoke the buffer switcher. Start typing any substring of the buffer you want to switch to, and you'll see the choices narrowed down to only those that match what you've typed. You can even skip letters. Switching to buffer that doesn't exist will create it on the fly. Control K from within the buffer switcher will kill or close the one currently selected. To get out of the buffer switcher, Control G as usual. Now here's another nice thing. It starts with the most recent buffer. So you can switch between two buffers easily by just doing Control X, B, Enter, and then Control X, B, Enter again to switch back to the one that you were previously in. Now here's a slight complication with creating buffers on the fly. It's very handy and a very quick way to create a new file without having to specify the directory or anything, but you won't get automatic applications of your other modes. For example, if you create a .rb file, it will not automatically have Ruby syntax coloring and the other kinds of things. If you use the file find dialog, Control X, Control F, then you will get automatic application of your major modes, Ruby, Python, C, whatever else. One last tip: to see a visual list of all your buffers, Control X, Control B. This is a common interface in Emacs. You can mark things in one stage and then have a separate command to apply what you've done. You can go down and mark them one by one with D to delete a buffer, and you can go back and unmark them with U. When you're done, hit X. You can edit buffers forever without ever saving anything to disk, but most of the time you'll want to visit files and edit corresponding buffers. We looked at this briefly, but here's a review. Control X, Control F will open the Find File prompt. You'll notice this uses IDO's instant feedback mechanism, just like switching buffers. There are a few other ways of finding files that come in handy. CX and the solitary letter F will provide you with a list of recently visited files. Control X, Control P will attempt to find the file that is referenced under the point, if applicable. Two other options. One, you could use just Launchbar or Quicksilver to send files to Emacs and they'll open. Or, if you want from the terminal, call server start either in your config files or on the command line metax server start, and then you can use the Emacs client application on the terminal. For macOS 10, it's in Applications emacs.app contents. macOS bin Emacs client. You may want to alias that in your shell so that's easier to get to. Once you've done that, then you can call that with the name of a file, which will then be opened. You can also call it with --no wait, which will cause the terminal to just send the file and then ignore any resulting output. One of the things I really like about Emacs is that you can subdivide the editing area to let you view multiple buffers at a time. To split the frame into two columns, press Ctrl X 3. You can jump between the windows with Ctrl X O. You can further subdivide a window with another Ctrl X 3 or press Ctrl X 2 to split it horizontally. If you want to close a window, Ctrl X 0 will do that. Finally, to go back to having the currently focused window be the only window, hit Ctrl X 1. When you've got a lot of windows open, cycling sequentially through them with Ctrl X O is pretty cumbersome. You can use Shift and the arrow keys to switch in a given direction. To save time when you want to open a new file in another window, you can use Ctrl X Meta F. I do this frequently enough that I've bound some of these to function keys at the top of the keyboard, or you could write a Lisp function to set up a certain configuration. If you'd like to open a new frame, use MetaX make frame, just typing out the name of the function. This frame belongs to the same instance, so it will share the same buffer list and global variables as the first frame. It will just be treated separately by your window manager. If you have another machine running X Windows, you can even create another frame remotely with MetaX make frame on display, which can be useful for collaboration. By this time, you've surely noticed that there are an awful lot of key bindings to remember. But don't worry, you don't have to learn them all at once. Here's what I've done. Get the absolute necessities down, like find file, save buffer, switch buffer, etc., and then jot down some ones that look handy or interesting, maybe even on a sticky note next to your computer. When you start to learn those, throw away the sticky and come up with a new set of stuff that looks interesting. I found this is a great way to learn. You'll be a natural in no time. Remember, if you forget the binding for a function, you can always invoke it via metax, and the help functions are also great for finding things you just can't remember how to invoke. We'll look at those next. Emacs is described as a self-documenting editor. Part of what this means is that it has great built-in help features. The tutorial, available via Control-H-T, has already been mentioned, but there's much more. If you want to know what any given keystroke does, simply press Control-H-K, followed by the keystroke to see what function it's bound to and what it does. The documentation for any function you know by name can be accessed via Control-H-F. You should also be able to jump to the definition of that function. For any variable, you should be able to look it up with Control-H-V. This will tell you what the current value of the variable is, as well as what it means. For more general help, there is apropos, Control-H-A. List any portion of the name of the function or variable, and you'll see a list of all the other functions or variables that have that in it, for example, frame. Most cross-references in any documentation lookup are hyperlinks, so hit return over the name of a function or variable to jump to its documentation. Emacs also comes with a reader for info documentation. Control-H-I will open the info reader. Emacs' own manual is distributed in info format, as well as the Emacs Lisp manual. In addition, many other third-party packages, mostly GNU projects, will have info documentation available as well. For programs that use man pages instead, metaxman provides a quick lookup to those, and it'll even prompt you for the name of the command. To get rid of any help buffer and its window, just press Q. Or you can kill it just like any normal buffer with Control-X-K. However, this will close the buffer, but leave the window. For many people, editing is where Emacs really shines. It all starts with the point. The point is where your cursor currently is. Instead of having a selection area like many other GUI paradigms, Emacs commands often operate on the region, which is defined by the area between the point and the mark. Press Control-Space to set the mark. Now when you move the point, or the cursor, using either cursor movement commands or by searching, you'll see the area become highlighted. You don't have to hold down the Shift key or anything, you just go to the next spot that you want to go to. Typing or pressing Control-G will cause the mark to go away, making the region disappear. You can do many things with a highlighted region, which we'll be talking about next. Pressing Control-W will kill or cut the current region. When you kill a region of text, instead of just putting it on the clipboard, Emacs pushes it onto the kill ring. This means that you can have access to a number of past kills rather than just the latest. Pressing Control-Y will yank back or paste the last thing on the kill ring. So far it seems just like the clipboard, but after you've yanked text, you can traverse the kill ring with Meta-Y. Repeated presses of Meta-Y will cycle back through previous entries of the kill ring, eventually looping back to the beginning. There are a few other methods for killing text. Control-K will kill all the text up to the end of the line, so this is useful if you're at the beginning of a line and want to remove an entire line. Repeated presses of Control-K will push lines onto the last entry of the kill ring rather than creating new entries. Control-Meta-H will kill the word before the point, and it also has the same behavior for repeated presses. Meta-W will push the contents of the region onto the kill ring, but without actually removing the text from the buffer, similar to copy. There's also a mark ring. When you press Control-Space to set the mark, it pushes the current location onto the mark ring. So if you want to jump back to past marks that you've set, just press Control-U, Control-Space. This is especially useful when you want to look at something in another part of a file. Really quickly, just set the mark, press Control-G to cancel the region, search backward or forward to find the other spot of the file that you want to be at, and then hit Control U, Control Space to jump back to your previous mark. You can set several marks and jump through to previous ones by repeatedly pressing Control U, Control Space. Now, it's not very easy to see which lines are marked or to delete, but there are only about 16 spots on the mark ring, so if you just keep setting marks, others will be deleted off the front. How do we get this far without mentioning undo, Control underscore? I've also aliased this to meta Z so that I can use the same key sequence that I'm used to in macOS 10 applications. This does override the zap function, which is usually linked to meta Z. When you hit Control underscore to undo, Emacs will go back and reverse the changes made to the current buffer. When you stop undoing and start typing again, it's treated as a new set of changes. If you start undoing again, then it reverses what you've just typed, and then it starts re-adding what you undid previously. This works very similarly to what you might expect from other applications. Speaking of which, once you get the Emacs habits ingrained into your fingers, it becomes pretty annoying to work without them. Well, the good news is many other applications have Emacs key bindings built in. Try it in the terminal, Ruby IRB, even things like Gmail. Other applications will often respond, as you would expect, to Emacs key bindings in addition to the native key bindings for the operating system. Here's an obscure but snazzy feature that is occasionally very useful. It's called CUA mode. Enable it with meta X CUA-mode and start the selection with Control Enter. Hit Enter again to jump around the corners. You can subsequently type text that will appear on every line before or after the block based on where the point is. You can kill the entire block with Control W. You can also insert auto-incrementing numbers with meta N, and you'll be prompted to enter the increment and which number to start on, things like that. Now, CUA mode may conflict with other key bindings for basic movement while you have it activated, so try it out and see what you think. You may want to disable it by calling CUA mode again with meta X. Commenting happens in several ways. First, to comment at the active region, press meta semicolon. Pressing this keystroke when no region is active will add a comment marker at the end of the line and move your point to the end so that you can start writing your comment. You may also want to see the textmate.el plugin for textmate-like commenting of either a line or a region, which will toggle between commenting and uncommenting that line or region. Or search for the handy comment or uncomment region or line function. See the PDF for a link to that. Completion is something that I've become used to. The starter kit includes Hippie Expand, which can be activated by meta /. This tries a number of different completion strategies and allows you to cycle through them. Here's how it works. First, it looks for other words in the buffer that start with the same letters. Then it looks for words in other open buffers. Then it will look for matches in the kill ring, the list of files in the current directory, predefined abbreviations, or finally Lisp symbols that it knows about. While meta / is not smart completion that you see in a lot of statically typed languages, it's remarkably good at finding the words that you mean. Just remember that it benefits from words in other buffers, so if you want to have your completion be smarter, you may want to leave buffers open after you're done with them. You can use Control Y to bury the buffer so it's still open, but it won't get in the way of the buffer switcher since it's at the end of the list. While the I do menu, Control X, Control I, is useful for finding functions in a single file, larger projects will leave you wanting more cross-file help. you can generate a tags file that acts as a database of function definition locations for your whole project. Unfortunately, the way you generate a tags file differs from language to language, but there is a program called Exuberant CTags on SourceForge that will get you pretty far in generating this. Installing it is a simple configure, make, install, but then you'll need to actually generate your tags file. To do this, let's look at using a shell within Emacs. Control-XM will start an Emacs shell, or you can run meta-x shell. Then type this incantation to find all Ruby files, pipe that through user local bin ctags with a couple of arguments, including -e to generate an Emacs compatible tags file. You may want to make a shell alias for this. The contents will look something like this. Once your tags file has been generated, use meta period to jump to a method or class definition. Usually you'll want to be over the name of a method or class that you want to jump to. If you're not, it'll prompt you for that. Find tag, and we could enter something like calculate. Now in this case, it's only one line down in the current file, but we'll show you how this works. Next, find the tags table. In this case, it's one directory up, bludgeon/tags, and it jumps to that line. For a more useful example, let's go down to the download line here, project.download, and again, press meta period. In this case, it will just confirm that I want to go to download, I hit enter, and then I jump straight to the definition of download. Now, one complication, if you switch to another project, you'll have to manually invoke meta-x visit tags table to let Emacs know that the tags file it's currently loaded is no longer relevant. Personally, I'd like to see somebody automate this. For example, look for a .git directory, consider that the root of the project, look for a tags file there, and then go to town. Now that you know the basics of editing, let's look at major and minor modes, and also we'll look a little more closely at customizing Emacs with Lisp. Modes determine how you interact with a buffer. Every buffer has a single major mode active at one time. The currently active mode determines a number of things, including syntax highlighting, also called font lock, key bindings, what constitutes a word or other syntactic units, and how indentation works. There are a number of ways major modes get applied. When you visit a file, the file name will be checked against the values in the auto mode alist variable. Each element is a pair, or a cons in Lisp terminology, and this matches a regular expression to a major mode. For example, we could look for all files called rakefile and open them with Ruby mode activated. And remember, you can use Control-H-V to see the current value of this variable. If none of the values in auto mode alist provide Emacs with a major mode for the variable, it'll look in interpreter mode alist. This will match the initial line or the shebang line if present. So, for example, we could look for Rubinius files which start with RBX, or maybe Ruby files which start with the word Ruby. Finally, if you encounter a file that these heuristics don't work for, the buffer will be open in something called fundamental mode, which is a kind of blank slate mode. In this case, you can always just manually invoke a mode like any other command. meta-x Ruby mode will automatically activate Ruby mode for the current file and the current buffer. If you're in a mode that provides indentation rules, you can mark a region and use Control-meta-backslash to indent the entire region according to those rules. Individual lines can be indented by hitting Tab while you're at the beginning of the line. Minor modes are where you start to really see the power of Emacs. Minor modes add functionality to other modes. Unlike major modes, any number of minor modes can be active for a given buffer at once. Some minor modes are global for all the files you're editing, and you only need to activate those once per instance, but most are buffer local. Here are a few. Fly spell mode. Fly spell mode provides real-time spell checking. This is pretty straightforward. Press $$ to get suggestions for the word under the point. The fly spell buffer command will check the whole buffer. You can also use the middle click, which is usually the mouse wheel click, to get the interactive menu. Here's another one, fly make mode. This gives you instant feedback about the code in the current buffer. What it does, it actually runs a copy through the compiler or interpreter with warnings turned all the way up, and the results get highlighted in the buffer. It means you can catch a certain class of errors much more quickly, so you don't have to fire up your test suite. Not all languages are supported, and this may use a lot of power if you're on a laptop, but it's pretty cool. Follow mode is another one. If you've got a file that's really long, you can view it in 2 windows at a time. Just split the screen with Ctrl X3 and hit Meta X follow dash mode. Both windows will show the same buffer, and when your point moves off the bottom of one window, it'll show up on the top of the next. Whitespace mode is very useful, but unfortunately it's a feature in Emacs 23, which isn't really out yet. However, you can copy and require whitespace.el from the Git repository or from the Emacs wiki. See the PDF for a link. If you're picky about the cleanliness of your code, you can enable whitespace mode. This will highlight any stray whitespace in your buffers. You can configure it to show trailing whitespace, lines over a given length, mixed space tab indentation, and other things. Red is for trailing whitespace, yellow is for mixed space tab indentation, and black is for lines that are too long. The whitespace line column variable determines what too long is defined as, usually 75 to 80 characters, and you can adjust this to taste. To clean everything up, hit Ctrl-C-N. This will remove trailing whitespace, get rid of tabs, and reindent the buffer, although of course you'll have to adjust lines that are too long. If you don't like this, you can revert with the general command Ctrl-C-R to revert your changes. So in order to use this in an older version of Emacs, such as Emacs 23 or Carbon Emacs that you downloaded, we can do a few things. First, we download whitespace.el. It's on the Emacs wiki. Next, we'll need to copy that into our directory with our starter kit files. So Emacs starter kit, I've put it in a subdirectory of vendor. You may have to make the vendor directory and then put whitespace.el inside of that. Next, we need to add the vendor directory to the list of directories that are searched for Lisp code that will be used by Emacs. An easy way to do this is go into the scratch buffer and type these 2 lines. The first one just adds the vendor directory to the list of files that will be directories that will be used to look for files. And the second one, similar to Ruby, just requires the whitespace file and loads that code into memory. Right now, this isn't actually active though. We have to evaluate this buffer so that that will be run, and we can now use this code in our current session. This is a great way to try out new code before you put it into your permanent config files. So metax eval buffer will evaluate all the code in the current buffer, the scratch buffer, and then you could go and activate whitespace mode in an individual buffer. You can see there's also a faster way with Ctrl-C-V to evaluate the current buffer. So far that we've done things interactively, but you're not going to want to hit metax whitespace mode for every time you need to open a new buffer. You're going to want to have it invoked for you automatically. But maybe not on every buffer, just ones of a certain mode. This is what hooks are for. A hook is a list of functions that get activated upon the activation of another mode. But a hook is just a list variable like any other list, so you can use the same functions to look up its value or modify it. This code will make whitespace mode activate whenever you enter Ruby mode. Hooks generally run at the end of a mode's activation after the major mode code has been run. Now to see this in action, I could reevaluate the entire buffer, or you could do Ctrl-X, Ctrl-E to only evaluate the line of code that you're currently on, or technically the last sexp. Put your point at the end of the line and then run Ctrl-X, Ctrl-E. Now when I open a Ruby file, whitespace mode is on automatically. Customization is at the core of Emacs. Any command can have a key or key combo bound to it. Here are a few of the ones that I use for F keys and other combinations. I also use a script called unbound.el that shows me all the unused key bindings. These are global key bindings, but there are also local key bindings. Global key bindings can be overshadowed by local ones. For example, control meta H is usually backward kill word, so it works like it does in readline, but Ruby mode has its own binding that overrides this. So if I want to then override this again, I can override Ruby mode's own key map, which is kept in the Ruby mode map variable. This is in the starter kit. If you look at a line like this, you can see that Ruby mode map can be overwritten with control meta H to then redefine it to backward kill word as it would have been originally. So key maps are variables like any other. If you want to use control H V, you can see what the current value is. If you want to know what bindings are provided by all the modes active in a buffer, you can use control H M and see a list. So far, we've just been covering general editing features. Next, we'll cover more specific mode. First, here's a language-specific mode, Ruby. Ruby files get loaded with Ruby mode automatically. This provides your basic indentation, navigation, and syntax highlighting. On top of that, infruby.el provides interaction with a subprocess running IRB for interactive Ruby sessions. To open up an inferior Ruby buffer, inferior in the sense of being a subprocess, not of being lesser, press Ctrl-C, Ctrl-S. You'll notice a window is displayed with an IRB-like buffer. This gets you the best of both worlds. You can enter Ruby, but it acts like a regular buffer, so you can use completion features, copy text from the back scroll, split windows, whatever. However, instead of up arrow and down arrow to go through history, use meta P and meta N. This really shines when integrated with Ruby mode buffers. For example, you can select a region and press Ctrl-C, Ctrl-R to send that region to be executed in the infruby buffer. So in this case, now I can go down to the infruby buffer. I can use my regular meta right arrow, right bracket key, and then call the extract name method with the URL, and then I'll see the automatic output of that executed in IRB. If you're not in a Ruby mode buffer, you can just use meta x inf-ruby, and that will invoke the inferior Ruby buffer from anywhere. Or press Ctrl-U before meta x, and it will ask you which Ruby implementation to use, for example, JRuby. I find this works best if JRuby is actually in your path. For example, I've tried to do this with Ruby 1.9 in a separate directory that was not in my path, and it didn't work as well. InfRuby can even interact with Ruby processes on remote servers. Here's a little snippet I'll put into the Scratch buffer, and then I'll evaluate this with meta x eval buffer. If you customize this with your remote host and then path to your Rails application, you can call Rails Remote Console and actually start up an IRB session with a remote server. If you have many servers, you may want to write several functions like this and customize the names so that you can call them individually. To be honest, I had a hard time getting this working right away, but you may try it and it may work with your server. Two other things. To look up Ruby documentation, you can use the built-in RI command bound to Ctrl-H-R. Tab completion is available, so you can start typing the name of a class and then a method and see the RI documentation inline in a new buffer. If you write Ruby on Rails applications, you may want to download and install Renari, which provides functionality you should find helpful while working with Rails. The structure of a Rails project can get rather complicated, so Renari provides navigation functions to jump around between a resource's controller, views, model, and tests, and it looks like it's even being enhanced to work with MERB. When you visit a file that's kept in a version control system, VC mode will automatically get activated for you. This provides a uniform interface that works across a number of different version control systems: CVS, Subversion, Git, Mercurial, etc. You'll see feedback in the mode line whenever VC mode is active. In this case, it shows the current branch. A colon indicates that the file has been changed since the last check-in. If I view a file that has not been modified, we can see that we have git-master to show that it is unmodified. In VC mode, you can diff the working copy with the most recent revision using Ctrl-X, V, and then the equal sign. If you press Ctrl-U before invoking this command, you can diff any arbitrary revisions or branches with tab completion. How about discarding changes? Ctrl-X, V, U will discard any changes since the last check-in. You can also check out any arbitrary revision with Ctrl-X, V, tilde. You can use a revision like master tilde 3 to get the third most recent revision. Often it can be more useful to view a file's full commit log. Ctrl-X, V, L will do that, and then view a given revision with F or a given diff with D. If you're visiting a file that's not in the repository yet, Ctrl-X, V, I will add it. You may have noticed that VC mode is rather file-centric. If you're using a distributed version control system that works on chunks instead of entire files, you can benefit from an interface designed specifically for that system. Magit is a tool for working with Git. It's built around the concept of building up a commit piece by piece rather than committing all your changes at once. Ctrl-X-G is bound to Magit status and will pull up the interface. Here you can see an overview of the repository, including staged and unstaged changes, untracked files, unpushed commits, and more. The solitary letter S or U will stage or unstage the change at the point, while capital S and capital U stage or unstage all changes. Tab will show a diff of uncommitted changes for that file. You can stage all changes in a file or specified chunks. The solo letter C will open up the commit buffer where you can enter your log message. When you're done, press Ctrl-C, Ctrl-C to commit all your staged changes, or if you want to amend the last commit instead of making a new commit, press Ctrl-C, Ctrl-A in the commit buffer. Remember, this really only works best if you haven't pushed changes yet. From the status buffer, type capital P to push to your origin repo and capital F to pull. You can also hit the $sign to see the output. Lowercase b will allow you to change to another branch, and capital B will let you create a new one. The lowercase l will show the log of the whole repository, G will refresh the status buffer, and as always, Ctrl-H-B will list all the relevant bindings. In addition, Magit has a very thorough manual. I've learned a lot just by scrolling through the manual. You can do a lot of things without ever leaving Emacs. It is, of course, an operating system with a text editor built in, but a lot of things are done on the command line. There are a number of ways to interact with shell commands. The most basic are the shell command and shell command on region commands. These will allow you just to enter a single shell command like print working directory, see the output in the buffer, or a shell command on region will work if you highlight something and then call shell command on region, enter the name of the command you want, for example, WC to count the number of words, and if it's only a line or a few lines, you'll see it in the mini buffer down below, 5 lines, 25 words, 191 characters. If you just want access to the shell you're used to, try meta-x shell. You can see here I have some Unicode characters that didn't display quite right, but I do have my shell. Since it's in a buffer, you can scroll back in it and edit it just like any other buffer. Functionally, it's all just a shell. Another option is eShell. This behaves like meta-x shell, but instead of communicating with an external process, all the shell primitives are implemented in eLisp. Everything about it is customizable in eLisp, from completion rules to the way the prompt looks. See eShellVC.el in the starter kit for an example of how to change the prompt. It also offers much better integration with other Emacs features. For instance, you can pipe the output from a command directly to a buffer. Here's an example. I can call ifconfig, pipe that to a new buffer called interfaces, and then if I switch, I can see the full output. Since it's got no external dependencies, you can use eShell on Windows machines that don't have Cygwin installed. Finally, if you administer a number of systems, you might find CSSH helpful. It's a tool that allows you to execute commands in parallel on many hosts at a time and see the results all in one Emacs frame. What else can you do with modes? Well, you can change your color theme, also called font lock. A common one in use is this one here, just called color-theme. You can download it. You can see a copy of all the different themes included and what they look like just in an HTML preview. Back in your Emacs, you can then customize this. I've set a specific font that I like to use. I use 20-point font, large enough, works well for me. Then you have a few lines. Add vendor color theme to your load path, require the color theme, initialize it, and then optionally set a color theme that you want to use. You can also, with Meta X, call a specific color theme and just see that on the fly what it's going to look like. Here's a charcoal theme, and I could also try the calm forest theme. If you're ambitious, you could write your own or just hunt around the internet for other color themes that aren't included in the package. If you've used TextMate, you probably appreciate the Yet Another Snippet bundle, which works quite similarly. Go down to the For You section where there are instructions. On the Downloads page, get the YA Snippet download, not the bundle variation, but just the regular YA Snippet. Once you're done, unpack that into your .emacs.d/vendor directory, and then you'll enter a few lines of configuration, as you can see in my topfunky.el that resides in .emacs.d. Just these 4 lines are all you'll need, and then when you open a variety of different files in different modes, you'll have access to snippets. Some of these you can see up in the menu, or I'll show you later how you can find the directory. You have things built in like CLS. I've added one of my own where it uses some mirroring in order to mirror text across multiple lines. It works pretty much the same way that TextMate does. With the exception of the snippet files themselves, they're in a directory under the YA snippet directory, sorted by mode. You can see Ruby mode there and a bunch of different strings that you would type and then hit tab in order to activate those snippets. The content of a snippet is almost exactly what you would see in TextMate. Here's one that I wrote for myself that I enjoy. You can have some comments, and then you use $1 with placeholders, defaults, mirroring, and a final stop with $0. If you're a TextMate user, you may enjoy the TextMate.el from Chris Wanstroth, co-founder of GitHub. Download that, drop it into your emacs.d vendor directory, add these 3 lines to your username. I've got these topfunky.el, and that will then activate that basically for every mode. What that gives you is a couple different equivalents to TextMate for commenting and uncommenting a line. You can also use Command T to jump to another file within the current project, assuming that you're in a Git hosted project. Or you can use Shift Command T to jump to a symbol. Now there's already an equivalent in Emacs, but that just makes it a little bit easier if you're used to TextMate key bindings. 2 differences you'll need to know about. This was written for Aqua Emacs, so not all of the keys work for Carbon Emacs. You could customize this in order to get it to work for yourself. Another thing is, initially when I installed this, it was looking for a couple functions that weren't there. Maybe they're included in Aqua Emacs. It's the comment or uncomment line and the comment or uncomment region or line. Fortunately, there's a paste that you can look up on paste.lisp.org, and that will provide you with those 2 functions. You may need to paste those into textmate.el to have things work properly. At any rate, a real boon for TextMate users. ELPA is the Emacs Lisp package archive. It's similar to other package managers like apt-get and RubyGems. To invoke it, press Meta X package list packages. Review the list of packages, Press I to mark the package under the point for installation. Press X to perform the installation of all marked packages. Package.el is the ELPA library, and it'll automatically take care of byte compiling the libraries and setting up autoload hooks so they're loaded on demand. It's quite nice. Most of the modes referred to in this screencast that are not built into Emacs can be installed via ELPA. For an example, I've installed CSS mode. I can make a new buffer of a file that I want to use CSS with, although, to be honest, as mentioned earlier, it would be better if I actually used Control-X, Control-F to make a new file, and the mode would be applied automatically. At any rate, I can use meta-X CSS mode to turn on CSS mode. I get syntax highlighting, indentation, and the other benefits of a major mode. You've seen a few cases where we've modified the default behavior of Emacs by writing Lisp code. This capability is at the heart of what makes Emacs different from other programs. So it's important to keep an open mind when you're trying new modes or third-party code. If there's something that bothers you, keep it in mind. There's probably something that you could do to improve it. The next step is picking up some Lisp. The Emacs Lisp Intro and eLisp Manual are very comprehensive and readable in the info reader. Once you've read the intro, pick a simple mode and read through the source, looking up key functions that you don't understand as you go. Try to come up with small improvements in the behavior of a mode that you use all the time. You'll be surprised how quickly you can get things done since you can execute the code and see how it works as you're writing it. I also found it beneficial to read through the code of the starter kit. It's fairly simple and it's well-written Lisp. Great way to get familiar with how Lisp works. At the time of this writing, Emacs version 23 is entering a pre-test phase. It's expected to be released in early 2009. New features include a better font engine and improved Unicode support, a native Cocoa version, directory local variables, a PDF reader, improved multi-file VC operations, and more. One of the things that can make software a pleasure to use is the community that surrounds it. You can continue learning Emacs and Lisp in isolation, but you'll be much more effective if you engage others. If you work with someone who's a seasoned Emacs pro, you're in luck. This is definitely the best way to pick up new techniques. But even without this, there are many resources you can take advantage of. The Emacs Wiki is often the first place to go for things that you can't find in the manual. It's got lots of advice, discussion, and code snippets that people find useful. It's even used as an ad hoc code repository. There's a fair amount of code that hasn't made it into the ELPA and is hosted only on the wiki. Of course, there's an Emacs mode called oddmuse.el for reading and making edits to the wiki without switching to the browser. Another useful resource is the Emacs IRC channel on Freenode. It's very helpful, and especially if you're writing some eLisp and running into trouble or wondering how to use a particular library, you'll find help there. To start it, meta-X IRC, and then join Emacs, ask a question, and get very helpful, friendly responses. Lots of people blog about Emacs and how they use it. A good starting point is Planet Emacsin at planet.emacsin.org.